Every cyclist has heard this sentence before. Carbon is stronger than steel. It's repeated in advertisements, bike shops, race commentary, and countless product launches. But there is one problem. It isn't actually true. Carbon isn't stronger than steel. Steel isn't stronger than carbon. The comparison itself is wrong. And that misunderstanding has shaped the bicycle industry for almost 40 years. Today, almost every bicycle on the Tour de France start line is made from carbon fiber. Riders trust it with their lives at more than 80 kilometers per hour. Manufacturers call it the ultimate frame material. But engineering has a rule. Every material is a compromise. Every design solves one problem by creating another. So how did one material become the answer to almost every question? To understand that, we have to go back to a time before carbon ruled cycling. For nearly a century, steel was cycling. It carried champions across Europe, survived crashes, crossed continents, and won nearly every major race on Earth. Nobody seriously believed it would ever disappear. Then came aluminum. Lighter frames promised faster climbing and a new generation of racing bicycles. For a moment, it looked like steel's reign was finally ending. But while cyclists argued about aluminum, another material was quietly being developed inside the aerospace industry. It was lighter. It could be shaped almost without limits. And it would completely redefine what a racing bicycle could become. Carbon fiber didn't win because it was perfect. It won because it solved one problem better than anything that came before it. But solving one problem is not the same as solving every problem. Somewhere along the way, cycling simplified a very complicated subject into a single sentence. Carbon is stronger than steel. It sounds scientific. It isn't. Engineers almost never compare materials that way, because strength is only one property, and even strength has several different meanings. Imagine asking a Formula One engineer one simple question. Which is stronger, the tire or the engine? The question itself makes no sense. Carbon fiber isn't a metal. It doesn't bend like steel. It doesn't yield like aluminum. It behaves according to completely different rules. Carbon isn't really one material at all. It is thousands of microscopic carbon fibers held together by resin. Change the fibers, the resin, or the direction of those fibers, and the material changes too. That means engineers can make one section of a bicycle incredibly stiff, while allowing another section to flex just enough to improve comfort. Steel cannot do that nearly as precisely. This is where carbon transformed cycling. Not because it was magically stronger, but because engineers could decide exactly where the bicycle should be stiff and where it shouldn't. At this point, carbon sounds almost perfect. Lighter, more aerodynamic, more tunable. So why do professional mechanics inspect carbon frames after almost every significant crash? Why don't they simply straighten it, like steel? Why do tiny scratches sometimes cause concern, while deep paint damage sometimes doesn't? The answer has almost nothing to do with weight. It has everything to do with how carbon fails. And unlike steel, carbon rarely gives you a warning you can easily see. Carbon's greatest strength is also its greatest weakness. It allows engineers to control exactly how a bicycle behaves. But that precision comes with a price. steel usually tells you when it has been pushed too far. Aluminum often leaves visible evidence after a severe impact. Carbon can be much more difficult to judge with the naked eye. That doesn't mean every crash destroys a carbon frame. Most don't. But appearances can sometimes be misleading. Carbon is a composite material. Damage may occur beneath the outer surface, inside the layers that give the frame its strength. That is why visual inspection is not always enough. Professional teams understand this. After major crashes, expensive race bicycles are often removed from service until mechanics complete a detailed inspection. Sometimes that inspection finds nothing at all. Sometimes it doesn't. If carbon can hide damage, why do professional riders still trust it while descending mountain passes at nearly 100 kilometers per hour? Because modern carbon frames are subjected to extraordinary testing before they ever reach the road. Fatigue tests, impact tests, torsional stiffness tests, thousands upon thousands of load cycles. A well-designed carbon frame is not fragile. In many situations, it is remarkably durable. The real challenge isn't strength. It's knowing what happened after the unexpected. Which brings us to another myth. Many cyclists still believe that once carbon is damaged, it is finished forever. That isn't always true. Specialized repair companies rebuild damaged carbon structures every day. In some cases, repaired sections can meet demanding structural standards once again. Not every frame can be repaired. Not every repair should be trusted. But the idea that carbon automatically becomes worthless after every crack is simply another myth. So, is carbon actually the best material for a bicycle? The answer depends entirely on the question you're asking. If your goal is the lightest possible racing machine, carbon remains extraordinarily difficult to beat. Its ability to combine low weight, aerodynamic shaping, and tuned stiffness change professional cycling forever. But if your priority is decades of repairability, long-distance touring, or simply owning one bicycle for the next 30 years, your answer might be completely different. Every engineering decision creates a compromise. Lighter often means more expensive. More aerodynamic can mean more complex. Greater stiffness may reduce comfort somewhere else. The bicycle industry loves certainty. The fastest, the lightest, the strongest. Engineering almost never works that way. Carbon did not become dominant because it was perfect. It became dominant because, for modern racing, its advantages outweighed its compromises better than anything that came before it. And perhaps that is the biggest lie of all. Not that carbon is better or worse, but that one material could ever be perfect for every rider. File closed. Next file. A frame with no tubes. A bicycle that looked impossible. And a design the UCI tried to erase. The Bike Files. Subscribe for the next case.